So most of us like to think that we're sort of able to stay at layer 3 and all of the stuff that happens above us doesn't really matter. And there's a common misconception in the rest of the world that IPv6 must be a layer 3 thing. What I'm discovering as I go all around the world and talking to various people, that the reality is that IPv6 touches an awful lot of things beyond layer 3. And so the contention that I have is that we as the folks that make layer 3 work, in our own self-defense, should be thinking about what all of those folks that are playing in all those layers above us, and in this case I'm talking about the OSI model with the original 7 layers all the way up to the application layer, and of course the financial and the political layers that seem to go on top, that we should be ready to give them guidance on v6, because if we don't and we let them assume that it's all layer 3 until they discover otherwise, they will come up with rather unfortunate solutions that we will still have to fix. So I'll start off by talking about a lot of the things that have changed and why IPv6 really is more than just purely a layer 3 issue when you're designing and rolling it out. The IETF did some rather spectacular large number of changes in rolling out v6. And to some degree, they just like changing things. They're not the ones that usually have to roll things out, and I think that shows. Some of the things that you will see as the biggest visible changes with your users in your network, certainly stateless auto-configuration or SLAC versus the more traditional DHCP for address assignment is something that's going to come up as a design issue. Identifying in users and machines, since they are separate protocols, users will have different addresses, and it's not always easy to correlate that one particular machine or user has a particular v6 and v4 address. There is a lot more of what I describe as interface magic. There's a lot more things with addresses coming and going, interfaces acting a lot differently than in v4. v4 really is much more of a static protocol. Not saying this is bad, just pointing out that these are things that we are going to have to get used to and train our staffs for. And there are a lot of organization and political challenges. One of the things is that it's very common these days that the network and backbone group runs routers and switches. But DNS is done by a services group, possibly by IT, possibly by the security group. DHCP may be run by a different group than either of those. They may have desktop and IT and DHCP while someone else does DNS. All of that has sort of probably settled out in your organizations now in a particular way. And with v6, because of things like router advertisement messages, there are suddenly things that would be considered DHCP-like functions or DNS-like functions that are now being configured into routers and vice versa. So an awful lot more departments are going to have to talk, and a lot of processes may have to change. Other things, applications are in for a huge amount of change. Browsers are the most obvious first round of those, and I'll talk about things like happy eyeballs. But there are suddenly major ways in which TCP sessions going in and out being affected by an address change in v4 doesn't happen in v6 in anything like the same way. How you pick what address, how you pick from DNS what address you get, all of those things are things that are now being done by browsers and by applications rather than by the operating system necessarily. And your application programmers have never had to think about this before. They're going to need a lot of guidance. PTR Records is another one of those. How we do PTRs is probably going to change. Your concept of what is appropriate on a single, I will call it a broadcast domain because that's the v4 concept. But essentially on link local, there are things that are happening in v6 that weren't happening in v4, and that may change your security policies on those local networks. There may be additional vulnerabilities that you had not thought of. IPsec is something that we all need to be concerned with. And in some ways, the biggest change is the fact that there is so much change. There are still more drafts than RFCs. There are still more drafts coming out every IETF, and there are still operational holes and ambiguities in the standards that are not yet settled and don't have a draft yet. So we are going to be seeing continual change in IPv6 for probably another couple of years. So obviously one of the big changes in v4 and with DHCP, we identify everything by MAC address. That becomes your key in the lease file, your database key. It's how you're identified. Well, the IETF decided that that was really broken because there are problems with MAC addresses, which are correct. They are not always unique. There's the sort of apocryphal story of the buying 10 network cards from someplace in Taiwan and discovering after you bring them up that all 10 of them have the same MAC address. And you can fix that, but that brings up the next point, is that you cannot usually change it in software on almost any OS. So even if it was unique, maybe somebody mucks with it and it's not. And if you have multiple interfaces, frequently they will identify with the MAC address, the same MAC address, which means that these days with a laptop where I have a wireless interface and a wired interface, in v4 I couldn't DHCP because I would get the first address and the second interface that would come in would say, you've already got a lease for that MAC address, go away. So the IETF decided to fix that. And one of the things they ignored was the fact that, yes, these are all legitimate flaws, but somehow, in spite of all of that, 99.99% of the entire internet gets there via DHCP and gets there being identified by their MAC address. And for some reasonably loose definition of the word, the internet does work. So it can't be a fatal flaw. Well, that didn't stop them because they wanted to get to that last 0.0001% and have something perfect. So they came up with the DHCP unique identifier, the DUID. And there are some things that it does distinctly right. One is the fact that it is a unique DUID per host. That's either as the server or as the client. Every network interface that you have has an identity association or an IA. That pairing of the DUID and the IA is a unique key. I can therefore identify for DHCP every single network interface and guarantee that they are not the same interface. And that works. So suddenly we can do that problem of what do I do with a multi-interface host with DHCP? Works great. Where it doesn't work so well, one of them is an awful lot of us actually have counted on the MAC addresses the way that we tie to this is Joe's laptop with this serial number that I need an asset tag on or whatever. And here is the address he has. Well, that'll work for v4, but the DUID isn't the MAC address. So when I go into the leases file to see v6 addresses, I don't know that that's Joe. So trying to correlate v4 and v6 to the same machine is very difficult. The other problem is that your DUID is stored in persistent storage on hard disks, for instance, the registry in Windows, and usually in your leases file on Linux and Unix-based systems. The first time that you try and do DHCP as a client or a server, if you have not generated the DUID, you generate it, but then you write it in persistent storage. Really cool. But I am in IT and I bought a laptop for engineering and it's a new brand, so I go through the whole thing and I test it and I load all the software that all my engineers are supposed to have, and I test it and I do a DHCP and everything works, and I say cool, and I do a ghost image of that hard disk and I reproduce that hard disk on the 11 other engineering laptops. And I forgot about the fact that it writes the DUID in the registry. So I now have 12 machines that all have a DUID already, so they won't create a new one, and it's all on hard disk. So I've recreated the Taiwanese problem through my own process. So that's the DUID problem. There are also people with, gee, I do dual stack, and how do I correlate all of that? I've got to get past that. So there are several drafts out there to try and address the problem of how do I get the MAC address in a v6, DHCP v6 transaction so I can correlate v4 and v6. The answer is there is a draft. It looks like it should be through the IESG relatively soon. I'll be finding out in the next couple of weeks where that is at the IETF. Hopefully that will pass. And the compromise right now is if you use a DHCP relay, the relay knows the end client and knows its MAC address because you did a broadcast, or it got the packet and passed it on to the actual DHCP server. if you have that hardware address, you can then put it into the packet with this new draft and then get it up to the server, and it can be written into the lease file as additional data, even though it's no longer the key. And that was the compromise. It does also depend on the fact that Microsoft and ISC and all the people based on ISC, DHCP will both have to implement it in their servers, and the Cisco's, Junipers, and all of the others who realize the users will have to get it in code. So probably a year off or more. Other alternative is the Circuit ID, Remote ID that an awful lot of people use for broadband anyway. Those do still work, and those are in v6. So that, if you're using that as your unique way of getting the user anyway for your provisioning system, at least that has not broken. So, happy eyeballs. IPv6. It's great. We all want it. So how do we get people using it? Well, the original plan was that as soon as you did a DNS lookup, if you had a v6 stack enabled on your box, what you asked for first was a quad A record to see if there was v6 goodness in that DNS label available. If that didn't work, you dropped back to v4. Unfortunately, what that meant was, in some cases, hosts would think that they had a valid IPv6 connection because they had some address configured, but they didn't actually have useful v6 connectivity to anywhere on the internet. And what that meant was every time they did a DNS query, they would look for a quad A, they would then have to wait for that quad A connection to time out, and then they would ask for an A record. And in some cases, those timeouts were approaching 2 and 3 minutes, which did not do much for the reputation of v6 as snappier. So they then decided, well, what we need to do is say that what users actually care about is happy eyeballs. You know, they stare at the screen, they want their content coming back, and then their little eyeballs are happy. And so we really don't care if it's a v6 or a v4 transit, whichever one works better. Then, of course, the IETF got into, well, gee, if they're always doing queries for v4 and v6 records for quad A's and A's, that's going to just drive DNS traffic through the roof. Well, yeah, it does, but DNS is relatively cheap. A lot easier than getting users back. And so they came up with various interesting definitions, and while the IETF was debating, some of the OS vendors, including Microsoft, and some of the, actually all of the browser vendors, major browser vendors, all decided that they would come up with their own solution that would be effectively happy eyeballs. And the result was chaos, because none of them did it the same, and none of them quite matched what the ultimate RFC did. So Jeff Houston from APNIC did some fascinating practical testing and then wrote a paper which he called Hampered Eyeballs, which was that in theory what should have made all of our users' eyeballs happy with content coming fast and snappy wound up being spectacularly varied depending on the failure mode, the browser, and a whole bunch of other stuff that was very non-deterministic. I would Google Jeff Houston and Hampering Eyeballs and read that paper. And the sad truth is that almost a year later, there are still different implementations on all the major browsers, and that Microsoft, which actually is probably the right thing for them, they decided we will fix it at the network layer, so no matter what your app is, you will always get happy eyeballs. Unfortunately, if you are not using Internet Explorer as your browser, which some people perhaps might use Chrome or Firefox instead, even on a Windows box, they have their own browser and their own rules, which is now fighting with the OS trying to tell it what it should be doing. So, interesting life. One of the other, there's an old joke about, thermoses, the things we put our soup in or whatever, and so the joke goes, keeps hot things hot, and keeps cold things cold, which is pretty amazing. But the really amazing thing is, how does it know? And so we have the same problem with an RFC. Was 3484, it's been updated to 6724, which has this fancy name of Source Destination IPv6 Address Selection. Because one of the exciting things I said was there's a lot of magic, and you can have multiple addresses per interface, multiple routers, multiple prefixes, all this cool stuff. Okay, so I am an application, I'm about to open a network session, and I'm going to construct the packet, and I've got 5 source addresses on that interface that I'm about to send it out. Which one of those is the address I should use? Well, and some of them are obviously better choices than others depending on where you're sending it. And so this RFC makes the assumption that your destination choice should, as best possible, be matched by the source address that you choose, so that you choose the best path. I.e., if I have a prefix that is for my company, and I'm sending to some other host that's in my own prefix, I probably don't need to use my privacy address that I use for out on the internet, and I certainly shouldn't use link local. I should probably, since I have an address in that same prefix, stay within that prefix so I stay within the same aggregated routed area. Okay, all cool stuff. But it turns out it's not that clean. There are lots of kinds of addresses. Global unicast is what I recommend for everything everywhere other than link local, but people will probably want to use unique local in some places, and there are a few appropriate ones. You have v4 and v6 addresses on dual stack. And some of them have better paths, and maybe some are less congested or more congested, and some of them make sense based on just the pure addresses, but you don't know that one of them has transit that costs you 4 times as much. So they have a standard, and then they let you change all of the kernel routing rules and precedents with your own algorithms, so that if it wasn't non-deterministic enough for you to figure out how that host chose to send that packet at that moment in time, when you're debugging it 2 hours later when you actually find out, you can make your life even more interesting by having local policies. So you actually need to know, because addresses come and go. Maybe the address he was using as the source address is completely gone and deprecated from that host by the time you get to debug it. Makes it fun to sort of deduce what happened, huh? And if you think this is mildly confusing, imagine what your first-tier support staff are going to feel like, or the poor IT desk, when the user calls up and says, "My web is broken," and you get to discover that it's some weird address mismatch or poor address selection. And because you need to know at the link local level exactly when over the wire, do you put sniffers everywhere on every subnet? Do you have a host that's on every subnet that you can optionally turn on sniffing? Do you do a spanning port that gets all traffic and have it off to some other IDS box? Do you hope for the best? Do you have your users turn on their own packet sniffers? Don't have answers. At this point, sadly, all I can do is pose the painful questions. And these are things that I have discovered from going around and having these talks, and then I talk to everyone afterwards, and they share their experiences, and then I go and I add that to my list of things in the talk cleansed of the exact person who said it. And I already have a fascinating variety of stories that will turn your hair gray. There's stuff that we haven't figured out yet because we're not using it in wide deployment yet. Things I'm starting to see now that people are actually trying this. The fact that you can have multiple default routes in a host without an active routing protocol is potentially way cool. No HSRP, no VRRP, none of the other crap, no running OSPF on an end host. In theory, this could be a great thing. I've already discovered that it doesn't work on all implementations, and the vendors didn't know because no one had ever sent more than one default route. I don't know if it's on the most current Fedora because I've not had a chance to check lately, but on at least supported versions of Fedora, when your preferred of the 2 default routes goes away, it does not automatically switch over to the second one and does not switch back if you can get it to fall over originally when the first one comes back, which breaks the protocols in the RFCs. It is very obviously a bug, but that doesn't really help the poor user who designed that or the sysadmin who thought that was the way of getting redundancy on their server. And other fun things was debugging with one customer who was doing stateful packet inspection of all DNS, which was a different problem, and which I tried to explain to them the reason why DNS works so well is it is UDP and stateless, and that making DNS fully stateful and deep packet inspected is a self-denial of service waiting to happen. But what drove it was they were getting all this V6 traffic, quote unquote, and they wanted to be able to disable V6 everywhere to see if that would help. And when we peeled down, what that turned into was they were getting floods of Quad A records. And that was, of course, overflowing the state tables of this stateful DNS, which broke all DNS for everything in their site. And what we discovered was AIX, at least some versions, even when it doesn't have V6 configured, if it somehow turns on link local, it starts sending out reverse pointer lookups and Quad A requests at hundreds per second to no purpose, which of course overflowed their state tables. So these are just sort of a couple of examples of the, how did this ever get out in testing? And the answer was, nobody had tested it yet. So what else will we find? Now we get into some of the things that are going to require some cooperation in groups. RAs. We already had in the IETF the whole everything should be in DHCP-v6 and it should be just like v4 and then our users will be happy. And we had the DHCP is stupid and broken and we like Slack and everything should be in the RAs and we shouldn't have to use DHCP at all. Well, v4 was pretty much straightforward. You configured it, you either statically configured things or you used a DHCP server and you got your default route and all that stuff. The downside, of course, was that if your networking group and your DHCP server group weren't the same and the router guys changed things and you didn't update your DHCP server, all of your users suddenly had a broken default route. That's part of the justification people use for RAs. Router guys playing with routers and default routes should be the obvious place to know what your best default route is. And probably in many cases that's correct. But v6, what are our choices? Well, you can statically configure if you like typing lots of hexadecimal characters. I don't recommend it. You can certainly use DHCP or Slack, but with DHCP you don't get a default route. That's been taken out, and as certain people will attest, the efforts to put that in have been fought off with extreme vigor at the IETF at every attempt. Yes, every single time. And again, their thing is, router folks, default route, they should say it. Well, okay. And here we get into one of those, it's usually a layer 9 political issue. Different groups control different pieces, and they usually control them because they don't trust the other groups to do something that matters to them. Most people wind up trying to control what they think controls their destiny and makes their life sane. And everyone has sort of settled out who does DNS, who does services, who does DHCP, and who does router and networking configs for v4. In v6, because of the fact that we have DHCP v6 doesn't have certain things and the RA is suddenly there and wasn't before, different groups may very well have to deal. And PTRs. It's not quite as horrendous as Vint Cerf's. I apologize for 32-bit addresses in v4 because we were short-sighted. But I should apologize. PTR records, or the way we now use PTR records, was the fault. I was one of the original employees at UUNet, and at the time we were one of the large FTP sites on the internet. And our founder, Rick, had gotten very tired of people sending email saying, your anonymous FTP doesn't work, it's broken, because they didn't understand how to type in their email address as the password. And so Rick decided one day that anybody who was that stupid did not deserve to get to any of the source code on our machines. They were obviously not worthy. And so what we would do was we would simply do a PTR check. And if you didn't have a PTR record at all, we didn't at the time check to see if your forward and reverse matched. But if you had a PTR record at all, then you obviously had used Emacs or VI, and you could actually load a zone into a name server, and therefore you were worthy to get stuff from our machine. Or you had someone at least on your staff who was that competent. And then we started getting lots of stuff with Qmail being broken and lots of people with broken mail configs and the rest of that. And we said, gee, you know, that FTP thing did cut down on our stupidity email, so why don't we see if the forward and reverse for their SMTP relay is correct? Because if they can't make the forward and reverse match, again, obviously they don't really deserve to send email on the internet because they are not clued. And then people started using it for all sorts of stuff, and it started to be used for security devices and VLAN validation, and websites started using it, and people like the New York Times actually cared if you had a PTR record, and it got completely out of hand. And so, what do we do in v4? Well, obviously we could maintain it by hand, which was what the old guys did. Most of us, once we'd done it 3 or 4 times and gotten tired of it, wrote scripts, shell or Perl. ISC eventually started doing $generate. Possibly you had an IP address management system that did all of this for you. But in general, we would do all of that, and we would pre-configure every address we own. So if we got a /22, we did PTR records for the whole 22. If we got a /16 because we were really lucky, we just completely pre-did the entire zone file, because then we never had to worry about anything breaking or any user complaining if there wasn't a pointer record. And we weren't always sure anymore what broke and what didn't break anymore, because it had been so long we hadn't tested it, and we didn't feel like getting support calls, so we just said, we'll pre-generate. Well, in IPv6, let's do a little math. Single subnet is /64. 18 quintillion possible addresses. Because it does it in nibbles, there are 32 labels plus the IP6 and the ARPA. So there are a total of 34 labels long, which means that you are pretty much guaranteed that any PTR record in reverse is going to have about 60 to 70 bytes. So 60 to 70 times 18 quintillion bytes, which is so many billions of terabytes that my math isn't good enough to tell you offhand what the number is. But the answer is, if there's anybody here who has a disk big enough to hold one single zone file for 164, even if you're NASA, I'm really impressed. And if you tell me you have enough RAM to hold that in memory, you are lying, because you have defied the laws of physics. So what do we do? Well, one of the things obviously we can do is say that pointers were a bad idea. Do like I do, mea culpa. We were stupid, we used them, we should admit it was a bad idea. Stop completely. Unfortunately, it ain't gonna happen. We could pre-populate if we somehow managed to figure out how to exceed the speed of light. What is more likely is there are places where it is useful. It is nice to have the mail servers have reverse pointers. It is nice for all of the interfaces on all of your routers to have that in the loop back of all your routers and your network switches to have it. So, and that's not something that it's so hard to pre-configure with scripts or with an IPAM system to have. And if you then say, well, anybody that isn't big enough and important enough to do those is probably going to use DHCP anyway, and my DHCP server can do dynamic DNS updates while they're using them, and some DHCP servers are better at grooming away the cruft afterwards, there you go. That's probably what I'm going to be recommending for most people for now. There have been a number of people that said, why don't we just make up a record, and anytime you ask me for an IP6 ARPA, you have an option that just says, you bet, here it is, and makes it up on the fly. That works really cool if you're not doing DNSSEC, which is designed to not let you lie without getting caught. ICMPv6 is another big change. It's actually a good change. The types are much better and more clearly and more closely defined, so you can be much more surgically precise in exactly what network behaviors you do and don't want to run on your network. That's one of the things I think in v6 is a decided improvement. And it's used for a slew of stuff. Duplicate address detection is no longer being done by the DHCP server. It is actually being done by the end host, and it works for both Slack and for DHCP. You find your RAs, and you do Slack sending ICMPv6 messages. You find all of the various servers, NTP, DHCP, all sorts of well-known services can be found via ICMPv6. Path MTU discovery, very quick. In IPv6, what happens is the sender is the only one allowed to fragment packets. So any intervening box anywhere along the way that notices that the packet size that it receives is too big to fit into its upstream pipe, that box, wherever it is anywhere in the internet, is supposed to drop it on the floor and send back an ICMP message saying the packet's too big, make it this small. So if you don't get that ICMPv6 message, that guy will still discard every one of your packets, and you'll have no idea why, and you'll time out. Still used to be able to do connectivity tests. and there are a number of network errors that tell you what the problem is upstream of you. So you could indeed filter all ICMPv6 like some people do with v4. And as long as you don't care about having multiple hosts on the same wire with the same address, you don't need to actually be able to get DHCP, which is the only, or do Slack, so it's the only way you can get a prefix dynamically at all ever with a routable address. If you don't care about the fact that your packets may be thrown out somewhere else and you'll never know, if you don't care about pings and all that, and you consider that a usable network, not my definition, but okay, most of us are going to need to actually read through and figure out what to filter. This is actually an excellent operational RFC. The ITF did a great job on spelling out. These are pretty much the things that anyone sane must have working in ICMPv6 or you will have problems. There are things that some people might consider desirable in the second bucket and you need to think about it. Like if you're not doing mobile IPv6, then sure, filter all that stuff. And then there are certain things that they say, basically anyone outside of a lab who uses these is insane. And they more or less do it along those broad categories, so it's very straightforward. If you have security people who are arguing with you about what you should and should not allow and they don't know how v6 works, I find this is an excellent thing to point them at because it's short enough even your security guys will be able to read it. IPsec. IPsec it's one of the myths. IPsec and IPv6 is better than in v4 because it was designed in first and it is required to be there. That is the myth. And the reality. The RFCs say that you must support IPsec. There's some pretty good indications that at least the IETF will be softening that to should from must, though the US government at least will still be requiring must. Not great. Much worse, they didn't define support. So the guys that got to define support were your friendly OS vendors who, of course, always do the best job possible. And so what they decided was support means it comes under the distribution medium for your operating system, and if you can get it up and running, more power to you. And the other gaping hole, there is no PKI, no public key infrastructure. So what you are left with is you have to configure it by hand, and you must configure it pairwise in symmetric keys, which if it sounds remarkably like doing an IPsec v4 tunnel to a tunnel concentrator, you got it. So the good news is if you figured out how to do this in v4 and done the provisioning part, which is the annoying thing, and it works for all your users, you can do exactly the same thing in v6. The sad thing is it's not any better than it was in v4. And now we get to one of my favorite subjects, the IETF, who are a bunch of very intelligent guys without a lot of sense sometimes. So, yes, the more things change, the more they like to keep changing them, because we haven't stopped them yet. And this is, I think, now a month old, so it's already out of date again, but for DHC in the working group, there are 73 RFCs relating to v6, and 19 drafts still trailing their way through the process. And in v6, there are 52 RFCs that are considered current, and only 12 drafts at the moment, but every IETF meeting, they add more. So don't blink, there will be more coming. So as folks who actually have to make stuff work, and who have users who scream and rant and rave when their stuff does not work, what do we do? Well, the story is you can join the working group mailing lists, and that is the same as participating in the IETF Live. That is not completely correct, but I encourage all of you to get on and at least read and see what's coming down the pike and certainly participate. If you can, come to the IETF. If you can't, this is part of what the ISOC effort with the BCOP is all about, the best current operational practices. One of the agendas with that is getting a collective voice for all the operators that say, this is unclear to us, we can't implement in our networks, and it's not clear enough for our vendors to produce a solution for us, and here's the problem we're trying to solve, help us fix it. And then last, which perhaps may seem strange as a vendor, but beat on all your vendors, say it is important. Because when I say, there's this v6 thing coming down and we should support it because it's part of the standard, the first thing I get out of our product managers is, so what customer needs it? And how many dollars is the sale associated with that customer? And until I can answer those questions, I don't even get in the queue to talk to engineering to see if it will get put into the work list to eventually get into our roadmap of what actually ships to real people. Now, if I go back to our product manager and said, the entire network operating community of Europe thinks this is important, and they say, how big is that? And I can give them numbers of how big you guys are. I can actually get stuff done. So, questions?
Thank you, Jan George from Internet Society. Now, when you admitted the PTR thingy, you should wear a helmet, right?
I should wear a dunce cap.
Yes, full armor. So, I don't have a question. Just I would like to clarify one thing. You said that IPsec is a must, and it is going to should. That actually happened. With
Did it finally pass? Okay.
Yes, with RFC 6434, that's IPv6 node requirements, and I know that just because we had to sync that with the RIPE 554, and now the IPsec is a should, and there is an explanation why, because they said there exists sensors that are hardware restricted and cannot put the whole stack in it. And with mandating with the must, they would exclude all the sensors from being IPv6 compliant. So that's why they put should. Sure. But in RIPE 554, we said, okay, if it's not a sensor, and if you have any sane sense, you should probably require the IPsec as mandated in your requirements.
Yes, and the U.S. government has what's called USGV6, which is their standard that all of the federal government must comply with. And they have said must regardless of the RFC as well, but they've specifically mandated that it is for end hosts, for routers, and for service machines, specialty service machines such as DNS servers. So they've specifically excluded embedded devices and a whole range of other things, and probably for a similar reason. So
does that mean they will not implement sensors in the tanks and battleships?
They will, and they will be grossly oversized, and our defense contract industry will be thrilled to have them overpaying.
Thank you.
Tor Andersson, when you say that, I get the impression that one of your messages is that kind of IPv4 is static and stable, and IPv6 it's just a continuous flow of change which you have to keep up with. And I would like to say that it's IPv4 is also an evolving protocol, and if you kind of count drafts and RFCs that are being published that involve IPv4, especially now when we're actually running out, it's a lot going on there as well. So in this sense, I think IPv4 has been evolving all the time. It continues to evolve even today, even on its deathbed, so to speak. And the same thing is true for IPv6. So maybe IPv6 has a higher rate of change, but still you have to be on top of the technology and you have to evolve with the technology. So in that sense, I think it's kind of the same thing. And also, for instance, when you're talking about DHCP, I'm perhaps not old enough, but my impression is that the IETF didn't decide to throw out DHCP and go for auto configuration. It's more that when they actually started work on IPv6, DHCP wasn't really as dominant and as what to put it.
That I'll disagree with. The IETF had not yet embraced DHCP for v4 at that point in time either. And so even though it was prevalent in the market because Windows 95 had come out several years earlier and Enterprise had heavily embraced DHCP, it was not well loved in the IETF, and the processes for getting those standards out had been painful. So to some degree it wasn't so much that it was wishful thinking. They were hoping that they could come up with a better alternative and convince people that DHCP was no longer necessary. And when basically everyone looked at it and said, yes, DHCP sucks, but we know how it sucks. And we are comfortable with that suckage, do it for v6. And the other reason it took 4 years was there were enough changes that doing DHCP v6 was harder because they had learned from pain to not let certain things be ambiguous like they had been in DHCP4 the first time. So I think they did a better development job of it the second time around, but I think they were somewhat reluctant. Yes.
Thank you.
Any other questions? No. Okay, so it looks like there's no more questions. Thank you very much for the presentation.